I've been doing so much digital stuff lately, I recently decided, hey, when I do an analog project, this is about the simplest headphone amplifier you can build. The motivation for building this was that the headphone jack on my laptop's broken, and I have a not too bad USB audio interface that I use while DJing, but the headphone jack on that audio interface A, only works with channel 2, which means that I can't use it when normally listening to music, and B, has, I think, a ridiculous series capacitance, so if you're using it with serious headphones, you lose all your bass, especially if you've got a low impedance headphones. Like my Audio Technicas are in the 30 to 40 ohm range. So I was like, okay, I just need a headphone amplifier. With my previous project of the DMX control module, I realized that drilling holes for jacks is a pain, because even this 1/4-inch jack has the spacing is not quite what it should be. So I discovered the amazing method of gluing the jack to the board upside down or sideways, as I did with all of these jacks, and then just soldering wires to it. So I use another one of these Recom isolating DC-DC converters, except this one takes 5 volts in and gives you plus and minus 9 volts out. The other one gives you just 5 volts, which is great because A, it gives you a split rail, and B, it isolates us so that we don't have ground loops. Just for a schematic, that's where did I put it? Here we are. So I'm using Dave CAD. It doesn't have adjustable volume because I don't need it. I might add that later. You can see there's plenty of room to modify the circuit. How do you pick the R's and C's at the beginning? Well, this part here is a high-pass filter that's meant to just block out DC offsets, because putting DC across a speaker is generally a bad idea. As long as our input impedance, well, actually, doesn't matter what our input impedance is, because whether it's 0 or infinity, this will, 100 nanofarads, 1 mega ohm. We're looking at a pole frequency of something like 2 hertz. Definitely much less than the 10 to 15 hertz that you generally aim for. And then the 10K is, well, A, because line level audio expects line level inputs to have around that much impedance, somewhere between 5 and 20K generally. And also because without the resistor, if the input is open, then you basically have a very, very, very high impedance open circuit, and so as soon as you unplug the input, you get insane amounts of 60 hertz noise in your headphones. Might even be loud enough to blow them. So you might ask, if you're a beginner electronics guy, doesn't the 10K ruin your pole frequency? Well, it doesn't, because when you have an input connected, your input is modeled as your input looks like source resistance, and the voltage source, or in parallel with the current source, same thing. And this source impedance is generally around 100 ohms, and that's connected in parallel with this 10K, so it pretty much shorts it out. So when you have a source connected, it's like that 10K is not even there. well, it's like that 10K is not even there from the perspective of this part of the circuit. It's definitely changes what the circuit looks like to the source. And you know, I could add some resistors over here. This seems to work fine. Although one thing is, I kind of just picked whatever op amp I had laying around, and as it turns out, you know, this plus or minus 9 volts actually gives more like plus or minus 10.5, and that just goes over the spec max rail voltage, but it turns out it works just fine. And another thing is, no matter, I've added 10 microfarad caps here, and I'm still getting very, very badly regulated supply. So I think I might just add a plus and minus 7 volt linear regulators between this and this, because you know, plus minus 7 volts gives me plenty of output swing. Yeah, that was a fun little project. Next step is to get a better op amp. Well, I don't know if I really need a better op amp, but add the regulators, get a different op amp, maybe add a volume control, might not be necessary. And then it turns out it's completely unintentional, but actually fits in an Altoids tin. So I might just cut that. And ideally, I'd like it to run off of AA or AAA batteries, but then I need to add another step-up converter for that. But you know, I've got my Minty Boost, and I can just, you know, I've got this USB for the 5 volt in. I could just connect that to the Minty Boost. It's a little hacky, but hey, that's what this is all about.